Hello everyone. Today I'll be demonstrating the changelog replication to watsonx.data target on IBM Data Replication on CP4D. Now changelog is a standardized method for documenting and tracking modifications made to a database schema or table over time. Now let's go to a live demonstration. I have already created the connection assets for Postgres and watsonx.data, with Postgres being the source and watsonx.data being the target. Now let's create a replication asset. Let's give the replication a name. Choose changelog as a business goal, Postgres as a source. Now let's choose our source schema, changelog demo watsonx.data wxt. Let's choose watsonx as a target. Now towards the right hand side, we can see changelog metadata table cleanup option. This option enables us to either clean up the metadata tables or retain them when we stop a replication. So there are three metadata tables that have been created for every replication to watsonx.data. They are namely the changelog DDL type to description, changelog transaction ID commit timestamp, and the changelog DDL table. As we move down, we can see our changelog columns, which we can remove or re-add based on our requirements. And sequence is a changelog column which we cannot remove, it's mandatory, and acts as a primary key to a target table. Now let's choose iceberg data as the target catalog to which we want to replicate. There are a few more watsonx.data specific parameters which we can change as we prefer. Then comes the target schema. I've left the target schema as default, which means that a changelog demo wxt schema will be created in the target to which our tables will be replicated. Let's create the replication asset. And let's start the replication. In the meantime, as the replication starts and initial sync is complete, let's copy this run ID. This run ID is needed because the metadata tables that are being created have the run ID suffixed. So let's go to our watsonx console. I have already written some SQL queries for easiness. Now let's replace all the hyphens with the underscores because hyphens are not allowed in a table's name and instead underscores are being used. Now let's modify the SQL queries with this new ID. So I have now modified the queries. It is to be noted that the metadata tables that we create will be created under IBM changelog replication metadata schema. Now let's check the source table that we created and which will be replicated. So let's do a select star on it. We have two columns and we have two rows, pk call, name call, and then we have the two rows. Now let's query a target database. Now before we query, let's ensure that the initial sync is complete. So over here we can see completed initial synchronization for test table 1. Now let's query the target table. So we have two rows with the op type insert and the other changelog columns such as sequence, timestamp, and transaction ID. Now let's also check the metadata tables. So let's go with the first one, transaction ID commit timestamp table. This will have the transaction IDs and the corresponding commit timestamps along with the job run asset ID, which is the same as the one which we are given in the name of the table. You can check, verify it here. Now let's check the second table, that is a changelog DDL table. The changelog DDL table will actually record all the details that are being applied to our source tables. So this is, as we can see here, we have one entry that is the create table statement for the first table that we have created in our source. Now let's check the third one, that is a DDL type to description table, which is a two-column table which has a DDL type which is an integer and the corresponding description which describes the kind of DDL that particular type refers to. So DDL type 0 is replication patch, DDL type 1 is create table, and so on. Now let's perform few more DMLs. So now we have 4 rows. Let's query the target table. So here also we have 4 rows with insert op type. and John and Steve is with PK call 3 and 4. Now let's perform an update operation. So we're updating the name to Jack is where PK call is equal to 4. Let's query the target. So we'll now be able to see two rows, one with update before op type and the other one with update after op type. So update before op type will have the old name of Steve, and the new one, update after op type, will have the new name as Jack. So now let's try deleting a row. So let's delete a row where PK call equals to 3. When we do this in the target table, we will not delete the row. Instead, we'll insert a row indicating the delete operation. So we have delete with op type delete and PK call as 3. Now let's try another DDL, that is creating a table without a primary key. Now this table will be replicated to target because changelog enables replication of tables without primary key as well. So let's check the contents. David and Alex, 2 rows. So we have 2 rows over here as well, David and Alex with op type insert. Now let's check the metadata table. Let's check the changelog DDL type table. So over here we should be able to see the create table being replicated. So yes, we have create table. Test table 3 is present here. Now we can see 2 entries for the same DDL type and same table. This is because with Postgres as the ingest, every create table is followed by a sync. So we have a create table followed by the sync of the create table, thus resulting in 2 loggings. Now let's update onto this table. So we now have the new name updated as George. Let's query the target table. So we have update before, update after. The old name was Alex and the new name is now George. So now let's delete from this table. Let's query the target. We have a row with op type as delete, and we have PK call equals to 1, which we wanted to delete. Now let's try another DDL, that is a truncate table. So when we truncate a table in changelog, the source table will be truncated, meaning that it will have no rows, but the target table will not be truncated. It will have all the rows as it previously had. So let's verify that. We still have all the rows which was previously present. We haven't truncated anything. Now let's check the DDL changelog DDL table to see if the truncate DDL is being recorded. So we can see the truncate table DDL is now recorded here. Let's try performing an insert to the currently truncated table. So the source side, it should be having 1 row. Target side, it should append to the already existing rows. So we have Harry with insert as op type. Now let's do one more DDL, that is a drop table DDL. So drop the table. We are going to drop. So you have dropped it. Let's do a select star to see if the table still exists. The table does not exist. Now let's try a select star over here. Check if the table exists. The table does not exist. And now let's verify with the changelog DDL table as well. The drop table should be recorded here. Yes, we have the drop table recorded here. So with this, we have shown the replication of the various DMLs as well as DDLs that are supported for replication to watsonx.data as target. Thank you.